All right, this is a real mess as far as looking, okay? I'll explain to you the meters, and that's the most important thing. This is showing the voltage coming out of the volt regulator from track power, okay? So I'm taking track power, which is at um, 17 volts. I'm taking it down to 8 volts. It's still 3/4 of an amp coming in, so it's not much power coming in. Then I'm feeding that to my, hold on a second, I'm going to get this story straight. Yeah, I'm feeding 8 volts into my puffer board and to the smart smoke. Okay, I've got an open um, thing here, there, and inside there is a probe. Inside is a second probe, which is connected into my circuitry for the sensor. The blue wire is a temperature probe. So where you can see there, we're at 118 C, 118 C, which is pretty hot. And it's regulated. My reference resistance is 470. I can't really get a good number on what the resistance is on my sensor, but we're putting out 4.5 volts to the heater. So at 4.5 volts, 4.45, okay. Hold on. My fancy tool has a timer so I don't run the battery down. Anyway, at 118, okay. Now I'm gonna blow on this thing and pretend the fan's blowing, right? Oops, it's blowing, right? Chuffing. I'm just gonna chuff, and I don't know what you want to watch, the voltage or the temperature. Probably the voltage coming in is more important. I'm going to blow it down. I'll try to hold that. I don't know if I can because I'm not watching it, but I am now. Okay, all right. There you are, 4.46. Let's see what happens. I took it down to about 70 degrees. And as you can see, it climbs back up to 5.8. As it's done that, we were down to 70, 5 volts. Now it's below 5 volts now. So that power really brought us back up to the 120 quickly. It should be leveling off. 122 should be leveling off. Okay, kind of leveling off. So if the fan was broken, we would be shooting around 123, which is fine. And this is a carbon fiber lid too, by the way. So this is my high heat resistant lid. And I'm at 470. I may want to go to like 500. Yeah, I may have to rig this is just a box for test, right? So I may have to, when I put in the real resistors, put a combination that gives me 500, like a pair of thousands or something like that. But 120, 122, that's just about as good as we want to get. The 140s and 160s was worrisome, right? And that's at 8.25. I thought it was 8. It'll run up and down, see what's going on. As the train's running, you lose some volts. You're going to lose some energy, so you may have to do some adjustment. That's why I'm asking for those pots. But I feel pretty good. 4.5 at 120. Let's do it again. This time you can watch that, and I'll pop over to volts. .8 at a little less than 80 degrees, 100 degrees, 108, 110, 115, 120, Now it's going to overrun 122, 123, 124, 124, 125, 125, 126. $125. See, it overshoots and then it comes back down. So 480. And what was it? 5 something? I forgot already. At any rate, so the smart smoke is doing everything it's supposed to do. Isn't that nice? This guy picks up a hum, and I'm not sure why. I'll have to work on that. Maybe it's just loose wiring. That's annoying though, because that part is actually going to be in the tender, so maybe it won't be so bad. We'll have steam noises and all that crap going on. So let's see what time it is. 4 o'clock. I have about an hour. I don't think I can do much more. I might try to get a 500 ohm resistor, put another few ohms in here to get, see, now we're calming down. 122, 4.5. I feel very, very good. Let's see. Do I feel that good? Do I feel that good? No. Everything's a mishmash. I don't think I can pull it out and do anything intelligent. I don't know what's vibrating. It could even be just the transformers vibrating. No. Everything's all wired up goofy, not well laid out. I was going to put the 2 meters side by side, or all 3 meters side by side, so you could see them. That would have been semi-smart. Any rate, we're at 6 minutes. It's down to 120. You know, it'd be fun if I could take the motor and put it over there and see what happens. I don't know if I can do that. It's pretty stupid here, the way it's organized. I might be able to, though, if I'm... Oh, you know, maybe it's the fan making the noise. Isn't that funny? I thought it was that part. Oh, now the fan clip came off. That's okay. I can put it right back on. There we go. Now I can come over here and just blow on it with this fan and see what happens. Yeah? Just see what happens, if anything happens. Let's watch the temperature. I'll just aim the fan at it right now. It's at 106, 102, 101. What do you think's happening to the voltage? It's sticking pretty good to 99 or 100. Hey, you know what? That's with the fan on it. Now if I take the fan away, temperature starts to go up. Voltage drops, protecting the hot box. Voltage drops, and the fixture does not overheat. Now, that's successful, I'd say. This fan has a lot of speed at idle. I wish we could slow it down just a bit. I don't mind the idle. I understand we want that stream, but I'd like to have it a little slower so that the chuff has more difference. All right. Okay, so we're at 4.4 volts, 112 degrees. That's as good as I can get. I think, oh geez, I can't do anything. I'm so clumsy. Let's do this one more time and just watch the voltage. I have the fan on it. The fan is on it. The fan is on it. That's quite interesting. It's doing a different thing. Look at that, it's up to 147. I don't know what happened there. I don't know if I touched something. Everything's falling apart on me. It should be cutting it, and it's not. Still 4.5, still at 8.3, still climbing. Ah! Now it's dropping. It seems to take off and then take a while. I'm wondering, I'm thinking is the temperature on the resistor and the thermistor may react at different rates. The thermistor may be a little slow to pull the volts down, and then there's heat built up in this thing already. I don't know. It certainly doesn't look like it's 140, but I can't imagine this thing is in error because it's been fairly accurate all this time. Ooh, 126, 127, 4.5. I could have been reading like a lower number. 127. Now it's kind of peeking out. Okay. I think we're close though. I think it's in the 500 ohm range. That's going to get us where we want to be. I'm feeling pretty good. I think I'm going to close this down for now. And in an hour, I could fit this into that one. I could fit it in there. I could wire the motor, and I could wire the chuff, maybe. If I can find a soldering iron that works. All my soldering irons are crapping out. There we are, 126 at 4.4. I feel like this is now in the range of Dunsky. One thing I worry about is that chip is warm, but in my other prototype system that I put together, oh hell, that's not it. Here it is. I have a heat sink. So I'm going to put a heat sink on that dude and see if I can't give myself a little insurance. But that is the chip set. That is the board. And this was the kind of board that I have, Carl, for testing and putting things together. It's sort of a breadboard in that the verticals are connected, 2 rows. And I can cut one of these up and use about a quarter size of this board to build a breadboard of that. Get rid of all the jumpers and everything, and then send that schematic to you if you would like to help me make a real board, or look at your board and see if you can extend it in some fashion. That would be awesome to have smart puffer smoke. Oh yeah, baby. 125 degrees, 4.4, 8.3 going in. And that 8.3, the reason I jacked that up, I needed to have some dynamic range so we could get up to 5.5. This thing, with 8 volts, 8.5 volts, it shoots up nice and crisp, but it comes back down. This really manages it. When I put the heat sink on, I might be able to set this at 9 and actually get a better responding capability and see how that works out. Okay, I'm gonna post this just for us. I don't know, maybe I'll let it out, who knows. All right, talk to you later, bye.